Hello and welcome. We're here continuing on more functions for the Elm interpreter we've been working on, written in Swift, and we'll just jump back where we were. I'm not sure if this is a good direction to continue today or not. I don't know. I did a little research yesterday, but let's see what we got here for tests. At the end of the day, the other day, we added a couple tests. All right, let's run these, but while they're running, we'll look at them. So the first one, generic type is acceptable. If you have a lambda expression, lambda n goes to n, then, or lambda name goes to name, then the type of that thing is generic goes to generic. We haven't constrained the type at all. The one we're more interested in is where a generic type must be constrained. And we don't have a lot of options for that right now. I think the only one we have is really the if statement. So if you have an if statement that the result is either a float or an int, which comes out as number, then it resolves those types to a float. So let's see this test. We create a Boolean. There's probably a better way to do that, but anyway, lambda name goes to if true, then name, else number, else integer. And the integer type has number. The name is generic as far as we know. And we would like to have the function realize that, name, the type of the if statement is number, and the name argument must be some sort of number if we're returning it in an if statement with an integer. And so we would like to say the argument type, I guess you'd say, on name should be number, a string or a Boolean or anything else. We can't say if true, then true, else two. Okay, so we need to constrain this thing. I dug out, I don't know, I have a few compiler books, but not as many as I used to. I used to teach the subject for a couple of years there. I dug out my Dragon book and looked up the information on polymorphic types and how you do them, and it's more complicated than I was expecting, I guess. So we had this type passing already, but this function failed. Okay, it came back with generic goes to number instead of number goes to number. So I am not sure what to do about this. I know I don't understand the algorithm. So the algorithm they use is a unification algorithm, and the idea is you pass in two trees or two sets of, well, at least one's going to be a type restriction, so some sort of type restrictions, and another set of type restrictions. And unification is you try and match them up so that the corresponding type restrictions get identified, and we can force their types. So we're doing a small example of that here because we have the type names. By default, it's generic, and in here it's really unconstrained as well. I don't know if it needs to be. Boy, yeah, I don't know how we'll do that, but at any rate, the name, the only declaration of it is in this lambda expression, so we have no way of knowing anything about its type. We just know it has a type, and if you evaluate an if statement, we know that a generic combined with some sort of number a generic combined with anything else in an if statement has to take on the type of the if statement. So the if statement's type is number because the right hand side is an integer value which has type number, and the variable, we need to realize that if integer value combined with a variable is legitimate for an if statement, we need to say this name needs to be constrained to be a number, so we get the argument type correct down here. And the algorithm for that is moderately, well, it's like a graph matching algorithm or something. It's, it fits on a page in a book, but we don't have the mechanisms right now to do it. So I'm a little hesitant to dig into it until I understand that better. And I don't want to make you, watch me read a compiler book. It's bad enough watching me stumble around in the dark some days, but I'll spare you that one. So I think I want to push it aside is what I really want to do. Let me open my to-do list and see what I think of that. Lambda expression should have a type. Okay, that's sort of a sub-problem of a deeper problem we have when we get multiple argument functions and so on. There's definitely something there. Sorry if you're hearing the neighbor's dogs. I'm hoping the mic cuts most of that out. All right. Gosh, yeah, I don't know. It's this impulse to put things off sometimes, and I don't know if it's a bad impulse or not, but it's like, I know I need to do something in this area. What I need to do is noticeably more complex than what I have here, and I don't really know how to do it. Like I read the chapter on type checking, and I don't think I have anything else that's... Well, I have a book on Haskell I've never cracked open even, so maybe there's something there. I kind of got out of compilers just about the time the functional languages really started getting some traction with Haskell and that sort of thing. And I never really got that deep into how they're doing their stuff. So, we started this project trying to do combinators and realized it's not a very good mix for working with what we're doing. We're still on kind of a long run bet that the grammar of Elm will be compatible with the approach we're taking. Usually you can make it work. But yeah, so I don't know. I'm tempted to either, basically I want to give myself some more time. Let's put it that way. So if I can do a little more research on this without dragging you through it directly, I think that's probably a good thing. But let's mark this. I mean, this is sort of my generic ignored. I don't know, maybe a little more. Maybe a TBD. But I'm going to store the name in my to-do list, so we'll have that. So lambda expression tests. Okay, and it needs unification algorithm. Okay, so there's two places I've run across this unification idea in my career, I guess. One is this notion of what do you do when you have some complicated expressions that impose type constraints and you want to force them to align with their types. Okay, that's one kind. The other kind is I used in grad school and then at some other points I've used Prolog. And Prolog, you write these expression things and there's a unification algorithm for them that basically takes two expressions, kind of forces them together, and that sort of implies the binding of variables. That if you have a constant match up to a variable, then that variable must be the same as that constant, and things like that. I don't think I can recall either one off the top of my head, either algorithm, the compiler one or the Prolog one. I do remember there was a publication on the Prolog one, and I remember there was a correction to it. But what the mechanism was, I think again sort of a graphy, just kind of matching up candidates and managing that. Well, okay. I think I'm going to revive this for today. I don't know. Let me go to Elm Lang and let's just see what else is on our list. I haven't bothered to put everything in here. Documentation syntax. Okay, comments we handle, literals we handle except for strings. We don't do lists. That again needs generic types. We have simple if statements. We don't do named records. We do anonymous tuples. We've run into stuff with functions a little bit. We haven't done operators or let expressions. Interesting, applying functions is way down here. We certainly haven't done modules, type aliases, any of that stuff. I kind of want to put off the type stuff. The operators might be interesting. Yeah, it's funny. In addition and subtraction. Well, I know there's a bunch of others, so it'd be nice to have that list. Yeah, I mean that's okay. It would be nice if we had some of these operators. So the challenge there, Elm used to allow you to define your own precedences for operators, and I think even create your own operators for things, but doesn't anymore. But the definition of those operators is, well, it's done in the system code. And I don't know, we haven't dug through that. Maybe that would be a good practice. All these modules, the list and the string and the whatever, they're files out there. I assume they get precompiled and built into sort of a library symbol table, but we haven't dug through and found them and looked at them. I know at least one version I saw of them, you had a lot of layers, and then down in the bottom layers there were primitives, and the primitives just called JavaScript function 1 and stuff like that. Now we could probably detect some of that, and maybe it wouldn't be a JavaScript function. Maybe I can rewrite the file for a Swift one, or an internal or something. Yeah, I don't know. Operators could be a little interesting though. I mean, they do have precedence. They make interesting expressions. They are functions. Let's see. Yeah, you can see here. You can put them in parentheses and call them as if they were a prefix function, or you can use them as an inline function. No postfix function that I know of. Here you see that currying. The prefix function takes 2 arguments. You can lock in the first one with this, and now we have a function of 1 argument, and you pass in the second argument. Parsing wise, well, you can when you have precedence, there's a few ways to go at it. So we're doing this recursive descent top down parsing. It's called LL, and you can define multiple layers. Let's see. Actually, I gave a talk last night and showed that off. Let me find that file. Okay, and this is just to get at the. Okay, so here's a grammar for regular expressions, A or B or C or D, and or bars and implicit dots to append things, and stars to repeat them, and plus repeats, and so on. Okay, this grammar, well, it's ambiguous, so it's kind of problematic, because if you have E1 or E2 or E3, you don't know whether E1 and E2 combined before E2 and E3, except the operators are associative, so it doesn't really make a big deal, but it is ambiguous. And to work with it and to put some precedence in there, because there's no precedence implied here, you could go to E1.E2, well, yeah, E1.E2 if you had E1.E2.E3 or A.B.C, or how about A.B or C, okay, you from this grammar you can't tell if you should put B and C together first or A and B. We know intuitively, from years of math, that it probably makes sense to do the more multiplicative, the multiplying operator more than the additive union alternation operator. We'd like that to have higher precedence. So you can rewrite the grammar. And this grammar, parsing goes to expressions. You can see that term or term is the least binding. Okay, so before I decide about or bars, I'm going to make sure everybody's done as many of these terms with a list of unary expressions as they can. And same thing, well, this passes through, but you got factors. So I could have A, B, C, D, E, or F, and I would know that I'm trying to get as many of the A, B, C, D, E's together as I can before I break up and go up here to get the or bar and then the remaining stuff. So a grammar like this basically does enforce precedence. There's kind of like one level for each precedence level. And it sticks in my head like Elm has maybe like a dozen or 15 or so precedence levels, which means you'd have to have a grammar that had that many for this approach we're using. Recursive descent is what we're doing in our parser. There are other kinds of parsers. One is LR parsers, where you usually have a parser tool, some sort of descendant from the Yak tool from way back when. You feed in a grammar, it analyzes it and creates a big table that it can interpret, usually a table. Another one that's also more of a bottom-up approach, like LL, is kind of let me start over. The recursive descent is a top-down one. You start looking for a parse. It says find an expression. You want an expression, find a term. Term, find a unary. Unary, find a factor. Factor, here's a letter. Okay, I got a factor. And then you work your way back up. The bottom-up ones, they start more from, I've got a letter. What should I do? Okay, well, it goes with it. It's next to another letter. Letter followed by letter. That sounds like the start of a factor, or, it's a factor in a term, and it's not a unary because there's no star or whatever. So the bottom-up methods work more trying to see pieces and then identify when they have them, I guess. Maybe it's a way to say it. Another type of bottom-up parser is called operator precedence, and it's a historically pretty old one. Well, all these methods probably came, 1960s, 1970s. So they're all the typical compiler ones are pretty old. There are other kinds of grammars these days that people use, like we did the combinator stuff. But operator precedence says, if you have a grammar where everything is of the form operand, operator, operand, operator, operand, maybe with parentheses in there, then you can use this operator precedence model that is sort of like you would do intuitively. You probably learned, like, I kind of think it was a grade school subject, right? Like PEMDAS, right? Parentheses, exponents, multiply, divide, add, subtract, sort of the order of operations kind of thing. The operator precedence, you basically define a table that says, basically, like, think of saying 1 + 2 × 3. You don't want to do 1 + 2 right away because the higher precedence is still coming. So you sort of build just enough to see if there's another operator, and if there is, you decide which one gets the precedence. And then if it's the rightmost one, you kind of repeat the process, because you might have another higher precedence thing to the right, or something. But it's not a crazy one. And I don't know if I mentioned before, I wrote a parser with that in graduate school, and I'd totally forgotten it and was going through some old papers and like, oh, I have done operator precedence. It's not terribly hard, and it might be a good fit for this because operator precedence can work with user-defined levels of operations, even if the user is Evan C. I don't remember how to say his name even, but the person who invented Elm. He defines the operator precedence. He could change his mind next month. I don't think he will, but he might come up with other operators or something, and we'd like a method that could do that. I feel like that might be a reasonable way to go. So the title for this episode is pretty clearly not right. It's more functions. Should have just been more features. Okay, so I think operators are a good candidate. I might want to take another go at this REPL. Hopefully, if we just do it once a week, you won't get too tired of that. But yeah, so the let expressions, they're somewhat interesting. They're going to feed into our symbol table stuff. So just like a lambda defines, like lambda n goes to something, the let statement, you can rewrite this thing in terms of lambdas. So, it's really it really is sort of a variation of that, or a syntactic sugar for that, an easy way to write a bunch of lambdas without spelling out lambdas all over the place. But you make these assignments, sort of temporary assignments, and then inside this statement, you reference those variables. So it's almost like you're setting up a new symbol table, and any reference that's in the new stuff comes from this stuff up here. And there are rules about, I don't know if this one's allowed to reference this one, but I think 16 is allowed to reference 24. The earlier arguments are not. And this is the one that's indentation sensitive. Okay, so you have to put your definitions here and here must line up. And I think that's because it's an expression. So you could say let 3, 4 equals, and then let blah, 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 blah in some expression. And so you want the lets to line up and the inner expressions. Yeah, we can have type annotations. Well, that might be something interesting. This one is, you're allowed to say, this is the type I'm going to define for this variable, which could be a function or a value like this. And in our problem that gave us the starting point for today, that name goes to if statement kind of thing. If we had already constrained name and said, name is going to have type string, that would have pushed off the generic function thing for another day. But all right. Yeah, so let's make that the plan. I'm going to take another go at this. I'm going to maybe do operators. I don't know. We'll put a question mark. And it may be that maybe I'll have this in my head what to do here better. This was just an example. We'll drop it. And okay. So, okay. Well, okay. I think at this point I should be passing the test. So we'll commit this and go from there. All right. We'll see. Okay, back to user interface. All right, so we have our view. That's the interesting thing there. We have the content view. And we've tried to do this scroll view thing. So what we were hoping was, if you use scroll view reader, that we can monitor this thing and then force it to scroll to the bottom ID. That did not work. The next idea I have, let's see if I can turn this thing off. Yeah. Okay, the next idea I have, well, I've seen examples, whether it's a good idea or not. We have one big text string for our log at this point. I'm wondering if each line were its own text object, if this approach might work in there. I don't know. I don't think we're forcing this. Well, maybe we are. We are monitoring that. But the new approach, I think we'd have to, well, we'd want to do something like this. So I think we can write a for each. Do we have one? Because I never remember how these things do. I mean, I think we get to say something like, no, I'm going to look. Sorry. And there's variations. Yeah, okay. So we can do, I think we can do this kind of thing. For each well, I'm thinking like line. I guess my thing will do it. Okay, so let's do view model dot session dot split separator new line. Okay, so I'm going to break this thing into lines. And I think this, we may need to do some performance work around this thing, but if I do this, and then where's this text end? Here. Okay. Tab. All right, and if we do line in. All right, so my hope is this will monitor this thing. When it changes, it'll run through and put the lines. Now, I don't know where this fits, if it fits there. Padding 20. Well, let's see what this does. Oh. Doesn't build. Okay, what's the matter? Failed to produce diagnostic. Wow, that's what you call less than helpful. I added this line and I added this line. The only thing in here is a text object. Let's take the on change out. Try another build. No. Failed to produce diagnostic. Is it not liking? Well, that's a constant. That's colors is an array. Well, I don't think I don't know, maybe I'm not allowed to do this computation in here. How can I? Okay, so I'm not so sure there. What I'm going to try and do, let's make a new published field. I'll just call it, well, I was going to call it strings. Let's find a better name. Lines is an array of string. Okay, so this is my output. Maybe the output is fine. Okay, so I'm appending stuff. Let's just keep lines synchronized, or the output synchronized with what's going on above it. And I'll do a little duplication. All right, and then, well, maybe let's just pull this out. Okay. Session.append, output.append, output.append, new line. Okay. So I believe what we have now is the output is always written to whenever the session is written to, and the only difference is one is a giant string and the other is an array of strings. And let's retry it with this output variable. And we may have some extra new lines to take out or something. Okay. Can I find output? Oh, maybe just view model dot. Failed to produce diagnostic. Oh man. This didn't change that, did it? All right, let's take out more. Okay, I'm just going to put the bare line in there. Wow. Let me do a cleaning build just to make sure. And this is pretty simple. We don't need this anymore. Let's take that out. For the moment anyway. Okay, so we have text. We have a scroll view followed by text. Where's that match to? The VStack. Okay, that seems like what I want. Wow. Can I just do this? Maybe it's the ID. Yeah, it doesn't like that. Okay. Now it finds a real error. Referencing initializer init content on for each requires string to conform to identifiable. Ugh. I don't want to fight this battle. Where's that example we had? We found that proxy example. To do. This thing. So it did a VStack. It just put colors for each number IN. That seems kind of okay. We just had for each up there. A VStack with a for each. We should be able to do text things. Okay, here's the examples again. Well, they did for each with IDs. An array of colors. I mean, it seems like .self would be okay for that. ID colon dot ID. They forced it in there. Let's try Swift UI for each array, for each string array. Okay. No. Oh, that one looked like it might be closer. Dot indexed, huh? Well, again, they've made it identifiable. That first one, we just put the number in. Okay. Why we have content view twice? That's an interesting question. Okay. Referencing init with content on for each requires it. Okay, but if I put an ID, can I do that? That I would think would say each string represents its own line. If you had duplicates, maybe that would not be so good. Let's try a build. Well, the build succeeded. Okay, let's. Oh, I don't know if I. Did I show line? Yeah. Okay. Let's move this over here. Oh, we are over here? Okay. Let's move this over here and this over here then. Okay. Good. All right. That's a little disappointing. Can we type? Okay, so let's do 3. Well, I mean, it's trying to do something. 4. The width is nothing to write home about. If true, then 3, else 4.0. Okay. Yeah, our scrolling is not happy. I don't know what we bumped there. Is it empty string? Yeah. Well, what's working, what's not, I guess. One thing that's not is this box should have a bottom. Another thing is we want our stuff left justified. another thing is we want the width. Okay, so some of that is stuff I changed, right? So there's the frame width. Let's see if we can do that. And alignment top leading. That might help. I don't want to do line limit nil because each of these should be a one-line thing. Now that's a weird way to start. Oh, interesting. It doesn't start out that way. It gets that way. Well, that's certainly promising-ish. Notice we have some extra new lines, so I'm not super happy there. Starting out is weird. Like, why does it... I guess there is no line, so there's nothing forcing it to be that way. The border column is around the V stack. Let's put this on our bottom marker, which eventually will turn off the string contents. It's just there so we can see it. All right, and I see it's kind of time for a break too, so we'll let this run and then, okay, that's more like it, I guess. Maybe we could start with something else. Okay, so I think we're kind of doing it. We haven't dealt with the scroll to thing, but we'll see if we can figure something out on that. I don't think we'll be any worse off with separate lines. And the way the output is coming, it is separate lines to start with. So it's kind of a more natural output if it's handy for the UI. So we'll take a 2-minute break or so and come back and we'll work a little more on the REPL and then go on from there. Thanks. Hi, welcome back. All right. I didn't check the timer before I left, so hopefully you had enough time to grab your drink or whatever. Let's keep dealing with this. So we'd like to... it has too many new lines in it, so let's fix that, and that's probably in our model. We probably don't need this. And this one, I don't think we need that. All right, eventually we'll get these lined up and get rid of the old way. Right now, nobody's looking at session. Okay, so if I evaluate 1, 2, 3, 4, 5. Is that what the REPL looks like? Or is there an extra line in there? No, that's pretty much it, isn't it? Okay. Yeah, so that's a slight improvement. If we keep going, we're trying to, whoops. What did I do? Yes, thank you, Siri. Go away. All right, we don't have the scroll to auto scroll. More's the pity. All right, so let's see if we can work that back in. I think I'm going to say this output approach is a keeper. So we'll get rid of session. Okay. Whoops. That's the one I want. Okay. We got the output string, the input, the interpreter. We have trim it. We output the trimmed input, evaluate it with that, and get the output result. Yeah, that's pretty clean. Well, it's not refactored, but I think in terms of doing its job, I think this is doing its job. So we're going to commit this. Switch to line-based output rather than one big string. Now the question is, where does this go? On change of view model session, like, well, view model session isn't there anymore. We've got view model.output. Proxy scroll to bottom ID anchor. That seems correct for somewhere. I don't know if it's correct for here. We got the bottom ID. Okay, we've got to unlock the proxy again. And this. Padding 40. I thought padding was the inside. We don't seem to... It must be the outside. Moves the margin the inside. We'll make it obvious. That's the V-stack, right? Let's try it there. No. Okay. How to remove margin. It's kind of the opposite of what I want. Let me just take that out. How to remove margin. How to control spacing. Okay, that may be more. I don't know if we can kind of quickly find where he's doing something. Text with padding. Okay. Oh, just dot padding after the element. Okay, maybe that's all we need. So vstack dot padding. Are you gonna like that? I think that is. Yeah. Okay. Well, it's a little better. All right. Now the proxy thing. Basically, as you write the line, if you see that model output changed, you should scroll to the bottom. Oh, and there's the padding for that. Maybe this one's not needed. All right, so we put something in that may force some scrolling. I guess the padding should show up after we evaluate. Okay. It's putting 20 around every dimension. Not quite what I had in mind. But, well, big spaces are good for us while we're trying to explore this scroll thing. So the bottom ID is the ID of that triple underline thing. Hey, I think we've done it. Okay. Let's take the padding off, the line limit. Framing, that forced the full-size frame. We want that. This padding seemed like the right place to put it. Gives it to both elements, or all the elements. Okay. If true, then 3, else 4.0. Okay, I can live with that for now. I think that's a definite step forward. We can, well, we can blank this thing out. Let's see if that still seems to work. Okay. All right. Yeah, so lots of struggling. Let's take a look again. Sorry. I don't know if I want to pull out anything. Well, it would be interesting to know if we could pull this out. Let's try it down here. If I pull it out of both elements. Oh, I might even like this better if it still scrolls. Now, I don't know what that first indent is. What's going on there? I don't see what that would be. Well, let's take a peek in here. Here's trimmed input. I mean, that doesn't look like it's adding any space. Sorry, where would the space be coming from? Like, it's got lines. Why would it indent the ones with the greater than sign? Right? This thing shouldn't even begin to know. I'm definitely confused. I don't know. I'm gonna. Let's break here. You're running. Okay. If I put 1, I expect to see greater 1 and 1 colon number as the lines in my array. Okay, so let's print output. I guess we should be able to just see it. Output is a published string. Oh yeah. Greater 1. Okay. I'm going to continue to okay. So I think the output value here is what's being fed into our display. The one, the greater than, and the 1 are both in column 0 or column 1, however you want to count them. Column 0, the first column. And yet they come out like that. Let's continue. Okay. How? It's got the line. It just writes the line out. The difference is we have the frame on the outside now. Okay, let me go back. All right, let's run this. Oh, we'll take this off. I almost want to check the replay, right? Yeah, no, it really was doing that. Huh. Well, we'll leave it like this then. I guess one more experiment. Let's take it off here. See if having it on the bottom one is enough to do the stuff we want. No, it's not quite looking good. No, that one really counts. Okay. Top leading. I mean, that's a useful thing. And that's what forces it to be left justified. But our thing didn't look right justified. Okay. Run one more time. Now, I swore the width was correct before, but the V-stack padding is inside the border. Okay, did we try everything in both places? Okay, apparently that's what's needed. All right. Well, good enough for now. All right, so we improved UI of REPL. Got auto scroll to bottom. Okay. Well, that's been a bit of a thorn. I guess I'm glad to have that done. So automatically scroll to end of stacks. Okay, I think we can take out this. That's interesting, but it's okay. All right. So today's the 11th. And our story was this. All right. Provide the REPL in the UI. We've improved it with that. We don't need extra lines there. Okay. I'm still dealing with all these functions, right? All right. Well, let's find these operators. Okay, so we may get part of things done. I don't know. We'll see. So Elm, I don't even know where to look here. I guess which Elm? Was it A? I never remember these flags correctly. Okay. Yeah. What would it be? It would be like string.elm. I guess I want the name. Oh, well, you just opened it for me, huh? How nice. Later. Okay, where are you? Open. Well, I mean, we can take a look at this. If I'm right, this is the string module definition. We'll find it shortly, but you can see they've got the type annotations for these functions, and then here they call native.string.isEmpty. Okay, so there's a native package or native string package, and they're just deferring the Swift Elm level function into the native one. And I think at some point, like, we could probably replace the native package, substitute in Swift functions that are acting like primitives and define those, as sort of a map. And I think that would be okay. Okay. And I guess the other thing to me is like, what can we do with this file already? Well, we recognize the comments. Docs, I don't think I've ever seen that described even. I assume it's saying like, hey, on this function, you should include this. There's imports. We don't do those. The assignment we could do, it doesn't really know what it means. It doesn't actually do much in here, does it? It's all deferring to the native functions. I mean, admittedly, you want string manipulation to be reasonably quick here, I guess, but I'm surprised nothing is doing its own job in here. Okay, so TextMate, will you please tell me where this is? Basics.elm test. Okay, so that's a test. Oh, so we got tests for the library anyway, somewhere. I don't know where they are, but this is basics. So comparison, less thans. Empty parentheses like that. We didn't allow that. I didn't see it described in that syntax doc either. I assume that means a lambda with no arguments. But good to know we need to do that at some point. All that stuff. So this is a giant let in comparison. So it's... All right, where are you? Open recent project. Charted Elm. This should be the real. Okay. Now this one is doing some of its own work. So is between let code equals to char in some expression, and it calls with the arguments. So like I'd like to find an easy file and say we can do everything in this file, even if it's the most inner basic little file, right? We can work from there out and get stuff going. So this one's still a little hard. Okay, I gotta figure out where these things are though. Name. And they, okay, search and finder. I think it's dropping them in my folder. Let's go back there. Did I do that? No. Yeah, they're under here somewhere. Okay, under Elm stuff. Packages, Elm-Lang, core 5.1.1/source. Okay. See if I can condense TextMate. Well, I wish I knew where all these were. That's open. I thought I could. Can I just paste this? Ugh. Can I open TextMate here? No. Okay. So annoying. Well, so Twitch Elm. Okay. Elm stuff, packages, Elm-Lang, core, this, source. I think I can just do this. Cool. Okay, finally. Here's that native folder. Let's take strings, probably pretty simple, right? Oh, yeah, there you go. These are all JavaScript files. So when it calls platform.native.string.javascript and it wants dot is empty, it's just mapping into these things. Okay. So that means string was pretty low level. Let's look at basics again. Here it's got these operators. Well, this seems to have all the operators, right? Okay, so we can get those in. Yeah, here's what I was talking about. The infix L, infix R. So it's saying left infix or left associative, right associative. And usually exponent is the only right associative one. Right. So let's find all the infix L's. They're sprinkled around. So there's 9, 6, 7, 8, and we wrapped around. And then the infix R, I don't know what you call that operator, the less than pipe one. I obviously don't hang around with the right people anymore. Okay, infix R. 6, 7, 8, 9. We had some zeros. 2, 3. Oh, a lot of R's. That does not match my intuition. I would have thought they would have no. Well, those are okay. I would have thought some of these things don't have any precedence thing at all. They're just there. No associativity. But right associative seems very weird to me. But notice and has higher priority than or. That makes sense. Wow. That's odd. But anyway, we've seen 0 through 9, infix L's, infix R's. That's why I'm talking about it being a little tricky, like the operator precedence. If I wanted to hard code my 10 levels of precedence in with 10 layers of grammar, that's certainly an option. It's a little weird. But you know what I think we can do, and this is probably a good project for the rest of the day. This file has all the operators that are in the. This is the Elm Standard Library, basically. So all basically sitting up here, right there, ready for us. We can see all these little operators: plus, minus, times. Did we see plus plus? We saw that somewhere. These little less than whatever operators. Equality. Okay, so I think if we just got these in our tokenizer, got all those things working, and then I know list. Oh, colon is an operator. Okay, that's good. That's for building lists. And string. I thought plus plus was an operator too somewhere. Can I do a global search? Find in project. Basics. Oh, we're still there. Okay. And dot dot, huh? Order dot dot. That seems odd to me, but okay. So I think both the parenthesized and unparenthesized versions are interesting to us. I don't know if they're do we parse them separately? I mean, you can see, 7 plus 3, you got to be able to parse the plus sign by itself. And you can call this thing prefix operator 7. So I think they're different. I think one's the prefix and one's the infix. All right, let's find those infixes again. 6 plus 6 minus 7 star. Okay. And that matches your intuition, or at least mine. Pluses and minuses are lower precedence than star, and exponent is higher than any of them. And okay, yeah, let's go there. And I'm inclined to just get all these operators as tokens. So we'll just take this list and borrow it and put it in our to-do. Okay, so one part of our story is tokenize, which is just get them all in the list. We don't need the ones that, I don't know what order means there. I'm going to trim out anything that doesn't look like an operator. Although those those are, well, no, they're not reserved words. They're actual functions in the language, but we need to parse the operators specially. So let's do that. Okay. Now the prefix ones, they really are just functions. So handling them might be the same as handling these other functions. So we'll see. But if I can get them simple, like maybe we could just get a rule that says, operand, operator, operand is a legit expression. And if we had that, that would be something. I don't know what that word is doing, but we'll just start there. Okay, don't need that. Okay. Now these operators, the thing to notice, I don't think it doesn't look like there's one of them that is completely standalone. Maybe the exponent one, exponent and percent. Okay. But notice like equals has two characters. It starts with equal, but I guess that one has no choice. Starts with equal, must be equals. Starts with slash, could be just a divide slash, could be a slash slash, could be a slash equals. So those ones are going to take some work. But let's get the single character. Let's do single character operators. And I'll say only. Okay, so I'm looking for ones that don't continue. We have plus plus, so that's not an option. Less than, pipe, less than, nope. This one. And this list is going to be short. Equals, less than's don't. Plus minus might be one. No, well, we can, no, that's not a single character one because dash dash is a comment. Okay, it looks like star is though. And exponent. All right, tokenize multi-character potentially operators. And that's all these others. Okay, slash plus. Yeah, I think that's good goal. All right, am I checked in except for to do? Yes, good. We'll put this at the top since it's what we're working on first. And I guess I'll put this at the bottom since it's all one story. All right. Single character operators, percent, times, and caret. Cool. Let's go to our parser. Parser tests. And the parser itself. Okay. So we had some single character tokens, I think. Oh, we want the Lexer. All right, and the Lexer tests. Oops. Lexer. Yeah, single character tokens. Okay, so these are ones where we know we have just one character. we have some of these other ones started already, but they're not there. Okay, so let's see a test for, well, left parenthesis will work. Yeah, so there's left parenthesis, right parenthesis, comma. All right, so we'll just make a test kind of like that. Okay, and our operators were star, exponent, and the other one, percent. Okay, so let's... percent, token dot percent doesn't exist. Jump there. Add that here, percent. Test should fail. Oh, we actually had tests for that. Okay, I didn't know we were testing that. Sorry, forgot that. So I didn't run tests. Not good. All right, so interpreter XView model session. This is dot lines. What do we call it? Output. All right, and he starts out empty string. View model dot output sub 0. And we're going to just split this up. Out sub 0, out sub 1. The first comes out to there. No more new line. Second to there. Input should be cleared, yes. Whoops. Other end. Well, that looks an awful lot like the other test, doesn't it? Interpreter logs it into session. It prints the type, yeah. But I think this test looks completely identical. I can say with its type here, maybe. Right. Should have this failing elixir test. Yes. Okay. Let's back this test out for just a moment. We'll run the tests again, make sure they're all okay. Oh, there are 2 failures. Something else went wrong. Where are you? Oh. I think that was a cut and paste error, wasn't it? Okay. Cool. Okay, let's put this back. Now, one test feeling. Did we take our second break? Man, I don't even remember. Tell you what, I'm just going to go grab a quick drink. I'll even leave this on. I'll be right back. Percent is not equal to error. Unexpected character. Okay, let's go back to our Lexer. And we expect this thing to act like a single character kind of thing. Where's comma? Okay, so we'll just copy this. All right, so case percent, single character token percent. All right, and then we got well, run that. Okay, sorry. Feel free to take a break. Okay, so I'm going to commit this. Add percent token. And I'm just going to add the next two directly. We had star. And up arrow. All right, both should fail. Oh, yeah. Token. Now both should fail. All right, and we can fix it in the Lexer. So star and up arrow. Now, you know, I'm seeing duplication again, right? So that's fine. Let's pass. Okay, so single character token. Just does a get next character and returns the token. All right. So what I'm going to in my mind here is some sort of map for these single character things. I don't know if it's worth it. You got half a dozen of them. We'll pull this one out since it's not in that group. I guess we'll pull him down. Yeah, these things. I mean, aren't they? I'm seeing this thing. Aren't those record types done with braces? Yes, they are. Okay, what do the comments look like again? Oh, it's always brace dash. Okay, so we don't handle that case yet. All right. Whoops. Sorry. So, okay, that's the single character tokens. Let's get those checked in. And Handle token star and up arrow. All right, let's go back to our list. Those are good. Okay. Now, some of these are going to be easier than others. Right now we have equals as a single character token, but we know that that's not true. I guess I can't lose these other ones though either. Wait a minute. Handle prefix operators. Well, I guess that's okay. Well, all right. So I got equals. I got slash equals slash or slash slash. We'll just take them one at a time, I guess. So nobody else starts with equals, do they? We don't have a equals greater or anything like that. JavaScript arrow. All right. So we'll take the double equals. Lexer, and then tests find equals. Yeah. Okay. And we want double equals. Okay. Add that to the token. Equals. Double equals should fail. All right. And oh man, it's hard to know whether to break apart this lexing stuff or not, because I don't know, at each level it seems reasonable, but in total, like, these are a lot of tests. The numbers are pretty complicated, admittedly, but still. All right, so let's go to the lexer. If we find equals, there's single character. Okay, so now we want to deal with it. I think we can make a method. Well, equals operator, we'll say. Don't want to overlap anything too much. It's like where to put it, I don't know. Maybe down here. Okay, so it was function equals operator produces a token and location. And right now, that's our implementation. So this should feel the same way. That should be a refactoring. I don't usually do them when I've got a red bar, but once in a while. It wouldn't have hurt to look ahead. Okay, still double equals operator, but that's okay. All right, so the pattern for these things is when you match something, you consume it. Okay, and you always leave the next character one that you don't match. All right, so we get here if we have an equal sign. So we want to get next character. All right, we got to decide, are we a single equals or a double equals? Well, if, what is it called? Next character, next CH? Oh, just CH? Yeah, okay. If the character is another equal sign, okay, then we know we've got the double equals. So we're going to return token.double equals and its location. And if we didn't see an equal sign, we're going to return just token.equals and the location. Okay, so if we come in with equals, well, can I convert token location.type to token. We just call it a result location. No, just location. Okay. Okay. Come in with a single equals. We get next character. We skip over it. If it was equals X, then we don't take the if statement and we just return the equals and the X is sitting there ready. If it's a double equals, we come in with equals, consume the first one, match the second one. We got to consume it. Okay. And we're ready to go on from there. All right, so this should pass. Good theory, eh? All right. Managed to break them both. Check token optional. Line 1, column 1. Well, yeah, he shouldn't be. Wait, why is that column 2? Line 1, column 3. Well, I've misinterpreted something. Okay, single character token consumes that. Oh, it is result location. Why do I have location and result location? Oh, result location is the starting location. Let's rename that. Well, let's fix it and then rename it. In our lexer. Okay, so we will use result location and result location. And then I want to rename that thing. And I think starting location might be a better name. Okay. Simple refactoring should pass test still. All right, so we got tokens, equals, and double equals. Okay. Down here, we've done Okay. What's next? Slash, slash, equals, slash, slash. Let's get all these in one line. Okay. And it's probably easier to do the first one first. Okay, well, that's a next nice set to do next. And I'm comfortable doing all of them at the same time. We don't do any divides yet, right? No. Okay. Divide. Not equal. And then a slash slash is like integer divide. Not what I was expecting. Floating point and an integer division. Okay. So that's, whoops, I did it again. Let's call that float divide and int divide. Okay. So float divide, that, maybe we want these two together. Yeah, it's kind of weird the way it treats that floating point issue, floating point versus int. And I think maybe it's just kind of probably a consequence of tying into Java so much. I mean, JavaScript, where you just have one number and sometimes they treat it one way and sometimes the other. All right, so we got these three tokens to get in there. Float divide, int divide, and not equal. All right, should be 3 failing tests. And looks like it's the right 3. All right, let's take the case of slash. And we'll call this slash operators. We'll put them down next to the other ones. Equals operators. All right, so we come in here, we've recognized a slash. All right, and the only two possibilities, well, the 3 possibilities, one is it's slash followed by slash. So if the character is now another slash, we'll skip past that character, return token dot double slash is integer divide with the starting location. Otherwise, if the character is an equals, same thing, get next, and a return. Not equal with starting location. All right. And if we get here, well, it's not // it's not /equals. We're still sitting on whatever came after the /2, like 5/2. So this is token dot float divide and starting location. All right. And I seem to have one extra brace here, don't I? This, that should be gone. Oh, it puts them in when you type. All right. Hopefully straightforward code, 3 tests at once. Again, a little off. Perfect TDD, I guess you'd say. But I don't know. I feel like it's getting at one group of concepts that are reasonably easy to handle. All right. Got another group of these. All right, and back up here. We got your less thans, we got your dots. Single dot is an operator. Well, it's a token, so it's legitimate to use. So we could do that one. Did we see ampersand by itself or bar by itself? I feel like we should. String, this is basics. Let's look for find in project. I'm looking for ampersand by itself. Not a separate operator. Interesting. Same thing for bar. Really interesting. Okay. Did we do %? We did, right? Oh, I don't want to delete it here. Let's see. Okay, so ampersand, ampersand. We got plus and plus plus. Minus. Let's get these things grouped. So less than or equal. Plus ampersand separate greater equal. All right. We'll take dot. All right, and Lexer tests. Now, I don't know, from a test point of view or how do I want to say it? You know, I've got a lot of tests that look very similar, and they really differ just in these two. I was playing with that idea of parameterized tests and kind of faking it up and building a little module for that. I think we may come in and do that next time. But I really just want to say arrow maps to this, / maps to that, and just give a big table of those and let something run through the examples and do them. The complexity of the test is super simple, right? It's very linear. They're all just check the token. It's kind of an internal test. Well, no kind of about it. It's an internal test, but it's a useful test. Now these, they're a little more complicated. Check tokens, they're expecting weird locations and stuff, but all these are simple ones that just want to pull out a token. That's pretty easy. Okay, so this is the dot, and this will be dot dot. Dot and dot dot. Okay, no member. Okay, tests that fail. Okay. And in here we switch on dot. Dots, okay. And again, as we go through this, you can see why people just use token generators for stuff like this. It's very repetitive code. So repetitive, I'm just going to borrow this. Next character, that. Whoops. All right. We start with a dot. If the character is a dot, it's token dot dot dot. Say dot. Otherwise, token dot dot. Starting location. Every path eats characters as it goes. All right, I think that'll pass. We'll check in. All right, so next time is Tuesday, 1 to 3 p.m. Eastern time. We will certainly finish these operators, the tokens for them anyway. Probably do the parenthesized versions too. It's a pity those have to be different tokens, but I don't know. At some point we have to figure out how we're going to handle the system version of this. Yeah, I can finally see. Yeah, we do these for 25 more tokens and be like, yeah, we're definitely ready for a token generator. A nice side project, but we're not going to do it. But anyway, I will hope to see you in the future. Thanks for joining me today, and take care. Bye-bye.